Welcome to this episode of AU Manufacturing Conversations with Brent Balinski, featuring one of the companies we're putting forward as part of our quest to identify Australia's 50 most innovative manufacturers. This is the first time we've ever run this campaign, and we absolutely, positively couldn't have gone ahead without the generous help of Bosch Australia Manufacturing Solutions, SMC Corporation Australia, and lead sponsor MYOB. MYOB is a business management platform that brings together key workflows to fit business needs. MYOB has been part of the fabric of doing business in Australia and New Zealand for more than 30 years and integrates manufacturing, inventory management and accounting to help businesses streamline business processes. Okay, Dario, thank you very much for joining us here on AU Manufacturing Conversations. Good to have you on the program.
My pleasure. Great to be here.
I'm going to ask you the first question that we ask our guests, and that stock question is, how did you get here and what do you make?
We make solutions for aerial data capture, and we focus on long-range applications like linear infrastructure. And that's a fancy way of saying that we build remotely piloted aircraft or drones to carry sophisticated payloads to take photographs of and scan infrastructure, so things like pipelines, power lines, railways, and increasingly mines and different sites. The way we arrived at this was the mission of Carbonix is really around making that data capture accessible, sustainable, and efficient. So reducing the cost and the various impacts associated with really getting a good idea of what a piece of infrastructure is doing so that it can be run more efficiently and ultimately keep the lights on for the customer. We're able to do that because we have a combination of skills in the business. The foundation of it is the carbon fiber composites know-how to develop airframes that are very light and very efficient and can cover that ground in all weathers in a way that's stable. That's enabled by hardware and software stack that is specifically designed around the aircraft and emissions. And the genesis for the carbon fiber composites capability and the ethos of the business to some extent is my background in America's Cup yacht racing. So having been exposed to that environment, to competition, to really trying to squeeze the last few percentages out of a performance vehicle and doing so within very strict time and resource constraints. That's really the technology that was spun off into Carbonix, and that has since grown into our aerial data capture capability.
And so the transition from Carbonix boats to what you're doing now, what year was that roughly?
Around 2014.
You mentioned linear infrastructure inspections as being a focus of what you do. Could you please tell me about if this was always the case, or did you sort of gravitate towards that niche?
We started out recognizing the need for carrying a significant payload over a long distance, and we're pretty open to that. Could be a variety of things. It could be a still camera, a video camera, a gimbal camera, a LiDAR scanner, a multispectral payload. But to get a certain level of resolution to make it useful, you're talking minimum 1 kilo, anything up to 6-7 kilos of sensor. You combine that with enough fuel to make the flight time competitive with what would be expected of a crewed aircraft. So something longer than what a multi-rotor can fly, which means that you can then operate it at scale and not have to have the pilot move around from site to site as the aircraft runs out of range. The initial thinking was this platform can service many markets. We can carry different payloads according to the application, but the platform is pretty agnostic and it has a pretty broad appeal. Then over time, having done some work for customers in agriculture, for example, as well as scanning national parks for invasive species, some military contracts, we narrowed down to linear infrastructure because it's a large market. The data is definitely valued because it allows great savings in the operation of the infrastructure. And it tends to happen in fairly low population density areas, which means it was very accessible early on when things like the BV loss beyond visual line of sight regulations were still maturing. So we saw it as a large market that we could move into very quickly and show the technology in a practical way that the customer would value. That doesn't mean we don't do the other applications. It's just a matter of priority.
And so earlier this month, you put out a release to do with a contract with Quickstep, and you've had a deep relationship with them for some time, it appears. And the contract was to make 40 of your new long-range UAVs. What's behind your decision to use Quickstep as a contract manufacturer, and you're eventually moving to have them produce all your drones, or at least the airframes for them? Is that correct?
That's right, at scale. So we are very good at Carbonix at the prototyping development. We can modify, we can repair, we can move very quickly to define a product that will do what our customer requires. But when you then sort of freeze that design and want to build 100, 1,000, that's a very different proposition. And Quickstep is very, very well proven and versed in that side of rate manufacturing to achieve a level of quality, of consistency over a long production run. And so it's been a relationship that's been growing and getting stronger. We've got to know them over time. They've done various work for us. And it was just a really good fit to say they have the capability. They know carbon fiber composites. There was obviously a little bit of us teaching them how we build our aircraft and them coming back with, ways to optimize that for volume manufacturing, which was very valuable. And being able to have that relationship means we as Carbonix don't have to invest in plant and space and that side of manufacturing. We can rely on the aircraft turning up as and when we need them and know that they're done to the relevant standard to be reliable and to do the job we need them to do.
You mentioned limitations like plant and space and how they could perhaps be something that other parties could take care of. Could you tell me about the size of your company as it stands? How many people are there, and what's the sort of spread of your team look like?
Our team at the moment is 28 people last count, a fairly strong engineering capability. And the interesting thing about the kind of work that we do is that it's very multidisciplinary. There are several streams that have to work together and be really well coordinated to produce a product that performs. So we have aeronautical engineers, mechanical engineers, electronics, hardware engineers, and a software team. And that's around both the product development and support. Then still in the engineering team, there's the flight test aspect to it. So there are pilots and flight test engineers that are out there putting hours on the aircraft day in and day out, continuing that testing out in the field. And then we have a couple of flight teams that actually go out to customers and operate and do flights, whether it's initial proof of concepts, what we call our partnership success program, which is effectively onboarding customers, showing them what the aircraft can do and getting them ready to adopt. And then the rest of the business is made up of the customer-facing side, which is obviously sales and support, and then management. And, I guess part of the engineering is also the in-house manufacturing, but that's the composites and the electronics assembly.
And so we're speaking because Carbonix has agreed to be a part of our Australia's 50 Most Innovative Manufacturers campaign, and thank you very much for participating. I'd like to know from you how you define innovation, and personally and or as a company.
It comes down to questioning the status quo and looking at first principles. So in my experience, it's very valuable to have cross-pollination, to bring in knowledge from other industries and applications to inform what might otherwise be a fairly closed sort of way of thinking. Point of fact, applying stuff that was developed for making sailboats go faster to making aircraft go further, learning from different problems and thinking at a level where you can recognize the key variables and come up with creative and innovative ways to address them. So using different tools, different materials, different processes, all in aid of improving the outcome and being very disciplined about testing that against reality, against nature. So one of the things I find fascinating is that process of coming up with an idea, thinking, as an example, if we made our wing half a meter longer and this different profile, that would give us more efficiency. And you have this hypothesis innate pursuing this goal of flying efficiently. And then there's a whole process of you stimulate it, you build a prototype, you put it in a wind tunnel, whatever it may be, then you fly it. And along the way, you're learning about which aspects of your theory were correct and which aspects don't work the way you expect them to. And you're refining your model of thinking, this is how I think the world behaves. And you get a feedback about, hang on, it doesn't quite work that way. Let me find out why and let me adjust my theory to reflect that and proceed in that way. And that's across the culture of Carbonix. We do that with the development of the aircraft itself, the business model, the way we approach customers and get their feedback about how they see our product working and what they would like to see added to the product to give them more value. So yeah, the short version is innovation is really about questioning the premises and testing and finding out whether your theories are correct or not.
We'd like to take another moment now to acknowledge our sponsors, MYOB, as well as Bosch Australia Manufacturing Solutions and SMC Corporation Australia. There would be no Australia's 50 Most Innovative Manufacturers campaign without them. Be sure to check them each out via the links in the show notes and give them a follow on LinkedIn. And as you've mentioned, there are numerous places where you can innovate, not just in products, obviously, but in countless other places within a business. I'd like to look at one particular area, and that's the case study in your nomination for the new airframe, which you said was developed with things like climb rates and remote communication considerations in mind. I'd like to know from you, is this the latest iteration of your Domani platform and some of the things that were involved in that project?
The way our model naming convention, I guess, has evolved is we started out giving each individual aircraft a name and soon realized it would become confusing for the customer. So we have Volanti, which is the smaller electric aircraft that carries a kilo for up to 2 hours. Yeah. Then we had the Domani, which is the petrol hybrid version that can carry up to 5 kilos for 5 hours, depending on conditions. And we've basically then evolved that into what we now call the Carbonix 3, which is what we're building now. And when that goes to Quickstep for production, it will become the Carbonix 4. But that's sort of semantics. In reality, what we're doing is adding capability. And the way we do that is we look at specifically what a customer is doing with an aircraft. And the climb rate is a good case in point. When you design sort of in the abstract, you say, okay, most land is horizontal and we need to have a climb rate that's within what would be an aviation standard or what we think is the reasonable safety margin, and we proceed from there. But then you go out into the world and you find out that power lines actually tend to run up very steep hills. And one of the requirements in that case is we need to be able to follow that line going up that steep hill. So that then causes you to revisit, for example, the engine choice, and you say, okay, we can select an engine that has a little bit more grunt, but that might add weight, or it might add a high fuel consumption that then requires a larger fuel tank, and that has repercussions around the rest of the aircraft, ultimately meaning you need more wing area to support it in the air. And because we have vertical takeoff and landing, you need a little bit more thrust on what we call the VTOL system. And packaging all that together, you get to a point where, yes, you can extend the wings, yes, you can add high lift devices, but there comes a point where you just want to develop a new wing and put that on the aircraft and get yourself that capability. So it's all around weight, carrying, and range. And again, our mission is to operate drones at scale, which means you need both flight time and communication range to really cover the distances that you need to cover to make it viable to really do this at scale. And so Carbonix 3 and Carbonix 4 are evolutions in the direction of carrying more weight further.
It's a kind of a different question, but it's something that was recently in the news. You have a partnership with H3 Dynamics, and hydrogen electric propulsion is something that seems to be of interest to people, not least of all drone makers. Could you tell me, please, about how you see it being adopted in the future and by the general industry and by you guys?
It's really about energy density, or in our case, power density. So the reason we went from a pure electric aircraft to a petrol hybrid aircraft is that the energy density in petrol is orders of magnitude more than batteries. So we can carry in the order of 8-9 litres of fuel and get 8-9 hours of flight time out of it because there is just that much energy in the petrol. And obviously that then requires complexity in terms of having a generator to convert that fuel into electrical energy. Now, if that energy storage were hydrogen, theoretically that energy density could be comparable or even higher, and there would be the added bonus of it not producing any carbon emissions. In order for that to work, there are some problems that need to be overcome in terms of storing the hydrogen, whether it's as a compressed gas or infused in a matrix or whatever the method might be. Now, we've partnered with H3 because they specialize in this and they have solved some of those problems. They have a way of both containing and dispensing the hydrogen, feeding it to a fuel cell that then converts it into electricity, basically. Now, In our case, that would still be combined with a sizable battery because power draw during the vertical takeoff and landing is a lot higher than during horizontal flight, and the hydrogen will be very suited to providing that trickle of power for horizontal flight, but wouldn't be able to generate that burst that we need for vertical takeoff and landing. But it's a technology that's evolving, and when it gets to the point where it offers us a comparable energy density in a comparable form factor, then it would make sense to adopt it.
It's a very sort of open-ended question, but you've been watching the industry of UAVs develop for some time, and your company has gravitated towards one particular sector, and you've seen others do the same. What do you see as some of the interesting applications that will drive the growth of the drone industry into the future? Do you see it as being logistics-focused or surveying and surveillance or something else? What are your thoughts?
I think the premise is that drone is a very broad word. It describes a remotely piloted or autonomous flying machine, and it can be anything from something that you hold in the palm of your hand that might go over a house or over a hill and give you some pictures from the air, to the big military aircraft that can stay aloft for days at a time and carry hundreds of kilos, and everything in between. So we have seen over the last 5, maybe 10 years, this sort of speciation. There's this development of different forms of aircraft for different applications and niches. I think in our case, the reason we're focused on the linear infrastructure piece is that can be scaled. So if you have an aircraft that has the range, both in terms of flight time and communication, so eventually there will be a satellite communication, you can cover these vast distances in large areas, and you can operate what we refer to as remote one-to-many, which means you have one controller sitting in a room somewhere strategic, like in a city. They're looking at a screen, and there's a bunch of dots on the screen, and each one of those dots is an aircraft that's out there doing its thing. That's operating at scale. That's saying you've got these things really leveraging the labor that goes into one person supervising them, and have 100 of these things out there getting useful data day in and day out. So I think that's the future for the long-range stuff, and surveying is really where that value can be added, where it's just really giving information about the state of infrastructure, landscapes, farms, whatever people ultimately are trying to optimize. Then in parallel to that, there will be a transport element, and there's a lot to be learned still in that game, and there are some companies that are pioneering it, and that's everything from last mile delivery, and that needs to deal with flying over populous areas, dropping parcels off in the right spot without interfering with people on the ground. The traffic management element, once these things become sort of a lot of them flying in close proximity. But really there are low-hanging fruit like delivering critical supplies, so medical, whether it's medicines or medical samples to remote communities, things like that, where there's an obvious application where you could do that today and it would be an improvement. I think it's about scale and it's about specialization, and there's still a lot to be learned.
So the closing stock question, the last thing I'd like to ask you is there an issue within manufacturing that currently isn't getting the attention it deserves? What do you see from where you're sitting?
Yeah, I think there's a whole conversation to be had around that. I think there's a tendency to undervalue manufacturing, and that's both from a skills point of view, where there's a perception that building something with your hands is somehow less than working in a services industry. And so that means there's less of a supply of skilled people wanting to get into it, and realizing that it's actually a very good career, and it's something that can be both fulfilling and lucrative and very useful to other people. Possibly in the investment world, that's also an issue where manufacturing is seen as deserving a lesser multiple than say, software. But we do see that changing. We're seeing that ultimately being able to make something tangible is real value. It's something that you can point to and you can add capability and value to at scale. So I think that there is this cultural element that hopefully is changing, and it's down to recognizing that sovereign capability is important, that making things is important, and hopefully that'll evolve over time as well.
And so do you see the undervaluing of manufacturing piece where it concerns skills? Do you see it as hard to attract people with a relevant engineering discipline backgrounds to your company?
We've been fortunate because we are doing something that is seen as different and interesting, and we do attract talent relatively easily. We do have to train them. So we have an apprenticeship scheme, we have internship schemes. We're very keen on actually training and supplying those skills and putting them into our team and into the workforce.
Right, well, I believe that's everything I'd like to ask you, Dario. So thank you very much for taking the time to speak with us. It was great to have you on AU Manufacturing Conversations.
My pleasure. Thank you.
Thank you.